All right. So that's what you supposed to say here. So we are going to talk about fuzzing, right? So ideally, you don't really have to worry too much about. I'm not going to put bad words here. So you're going to put something like fuzzing, right? So what is this concept of fuzzing? So uh, this is somewhat important. Of course, you can do all these things that you did even without this, but it seems like for developers' perspective, fuzzing is something pretty useful, right? So the historical timeline goes to back in 1998 when this guy called Dr. Barton Miller, who's an academic, a professor from one of the US universities in Wisconsin, I believe, as I remember. And he was working at the night in the time of rainfall, and he was a bit upset about his Unix box. And suddenly, most of his Unix utilities started failing, right? So utilities, this different types of tools that you use in your box. Uh, so these things started failing, and then he realized, okay, so this is happening because of some other bugs. And then he realized why this, or what if I can find these bugs. And he found out a mechanism of uh, finding these bugs by sending some random set of values into these programs. So this was the starting point of this concept of fuzzing. Right? So to make it more simpler to understand, when you have a kind of application, right? So in application, so this application takes inputs, right? So this application takes multiple inputs. So you can provide some application inputs into this program dynamically, right? And then you wait until it crashes. Right? So you send some data, like if you, as you can learn, or I have learned it in format strings, you can send sort of data, right? So all right, so right, so that's basically what you mean by fuzzing. So you basically send some random values and then expect the application to crash. So once it got crashed, right? So once it get crashed, that's an opportunity for you to figure out is something wrong, right? So what is the problem? Then you can analyze it. Then you can find out a bug. So that can result in a bug, and then you can correct it, and you can have a safer system. So this is the whole idea about fuzzing. And there are so many different ways that you can fuzz, or there are so many special cases where you can fuzz, where the domain of fuzzing actually goes into multiple areas, which gives a lot of interest in terms of for cybersecurity people and for software engineering people. Right. So let me show you what are the areas which are available. So as an example, if you look at a kind of application stack that you guys working with, so you work with files in software, files and media, and you work with apps, right? So you work with a lot of things, and when you work with those things, you understand you are having. If you look at files, you have a lot of different types of graphic libraries. So graphic libraries are available, and also especially there's with files you have media handling. So for that you have memory handling here. So types of memory handling. A lot of functions are available, right? So in terms of software memory handling, and also OS system calls, syscalls. We have learned about syscalls in many places, so those are available, and also networking APIs are available. Network APIs. Okay, so that's also available, and then file systems. If you look at the file systems specifically, you have things like NFS. Even fat can be taken here, or even things like RPC, remote procedure calls. So there's a lot, no? And then if you look at apps and GUI, you have starting with IP layer, you have IP, and then on top of that you have things like TLS. I'm just getting random things, right? So don't think there's a structural thing here, no. And then the applications, so so many things, applications, but as we can have. So and also there can be things like wireless. So all of these things are different interfaces of this full stack. So these are different interfaces, right, in the software stack. So this, all these cases where you have an interface, there's a possibility to fuzz. So that's the scope of fuzzing. So it's possible to do things in many places. So this fuzzing is famous in terms of bug bounty as well, like spiking and fuzzing. So you can use something like a man in the middle proxy, MIMT, and then you can use like burp, and then you can say do fuzzing. So we learn that as well later on how to do fuzzing using burp, right? So that's possible, right? That's possible. But this is more or less into the system side, and not to say that we cannot use it for web. You can, but there are a lot more other usage. And also this is more successful in cases like C and C++. But we have learned that C and C++ basically rule everything in the web. So fuzzing is having a quite a say in many other places. And then of course, if you see, this fuzzing is used in many applications, and especially Google, they have this OS fuzz, right? And see, you all use this from cluster fuzz, right? So everything is there. So they have already set up the environment with this DevOps environment, continuous integration and continuous delivery. So they're using a fuzz, and they normally say they have already found out as of January 2020. So just want to show that how important this concept of fuzzing. They have found out over 16,000 bugs, right? 16,000 bugs, and over 250 open source projects. So they are specifically maintaining this in the. So this is the document. So they say the January 2020 they use OSS Fuzz Toolkit has found over 16,000 bugs in 250 open source software. So this is a very good opportunity for people who like to do like things like bug bounty exploitation. This is also another really cool area that you guys can work with, right? So, and especially when you do this environment, you can use Google Cloud if you want to. It will be much easier, because the other thing is when you start fuzzing, it might take a bit of a time. So to demonstrate it, so demonstration is not that hard. Let me take my where am I? Okay. Here. So I am using first a tool called AFL, American Fuzzing Lab or something, right? So so this is quite a famous toolkit. So I'm going to use that. So I'm not going to explain anything in the beginning because it might take a bit of a time. So there's a Git package, you can download it and install and all that. To install AFL, I'll show you how to do that. This toolkit. So here my plan is to run a command, so I don't have to wait because it might take a bit of a time to complete the process. So I'm just running that and showing you how to do a fuzz, and it might take a bit of a time, so it's okay. So what I'm going to do now, I'm here in this folder, and okay, so I'm going to this quick start folder. Don't worry what I'm doing, I will explain everything. All right. So there's this program called vulnerable.c. That's what I'm going to fuzz. If I'm open that program here, this PC is lagging. All right. Okay. So this is the program. So as you can see, it's a C code. So there are a lot of vulnerabilities in this code. So I'm not going to discuss anything right now. It's not the point of the lecture. So this is a code, blah, blah, blah. So, all right. So then I compiled it, and now I'm having this vulnerable object file, right? And then what I'm going to do is run that. Okay, run this. And remember, when you are compiling this, you have to set the GCC to use AFL, which is the American Fuzzing Library, or whatever the name it is. All right, so now this is the usage, guys. So it should run, so it should have some input. So actually the inputs are here in the folder CD inputs. So if I go here, I have two files, head and U. So if I cat head, so it has some strings in it. The head 220, this string is going to be truncated. Okay, so that's basically some input. So with working with format strings, you know the drill. Right? So we are going to set some input. So let me go back. So if I run this again, okay. So what I had to do is, okay. So I have to run this again. So I'm going to run this with inputs, say head or something. So it's going to truncate it and going to show something. So that's what it does, but it does a lot of operations which are vulnerable or buggy. Right? So that's what they do basically. So nothing to worry, just a C file, but it has bugs in it. Right? So that's the thing, right? So now what I'm going to do, so here, now I'll be able to run my AFL here, AFL fuzz. So remember, it's a fuzzer. It's a very intelligent fuzzer. So it uses something called genetic algorithms, which talk about later in a session. We can use machine learning for this as well. But there are dumb fuzzers as well. Dumb, you dumb. So there are them as well. So what I'm going to do is I'm going to run. Now I'm going to use the same inputs, guys. So my inputs, so for a fuzz, please understand there should be inputs for sure. And I'm going to set all my output. Basically, once it runs it will probably have some outputs if there's any crashes, of course. If there's any crashes. So assuming that I'll get some crashes, who knows? So I'm going to run it with out. I'm going to save it in the folder called out2 or out crashes. All right, and then I'm going to give the vulnerable program. So this might have a bit of an issue in my machine. Oh no, it's okay, no? This is cool. Yep, good. So now as you can see, this is the American fuzzy lop. Sorry, not the live. Right, so 2.56 process timing, runtime. So now see, it has this days, hours, what the fuzzing, you know? So meaning like the concept that you guys have to learn here, this fuzzing can take days, right? So it might take not hours, even days. So because it's a random method, you don't know what's really happening inside. It's a black box testing. It's not a white box. Oh, sorry, not the fuzzy, right? It's a black box testing, not the white box testing. So it might take some time. We don't have a much of a clue like what time it will run. Okay, and also there's a lot to learn about fuzzing. This is just a very basic lesson. But when you do fuzzers, you need to understand you can do it with CPU usage or GPU usage, but GPUs are not really used here. Like all the other guys, machine learning, gaming, we say, oh, GPUs are blah blah blah. For some reason, we use CPUs here, and you can see my CPU is working 645%. If I do a top, I believe I'd understand. Yes, new tab. Can I check the top? My machine is anyways lagging, so this will kill my machine. I don't know whether there's a top here. Add top. I don't think I will have my memory or CPU usage. Oh, it's really slow. Okay, let it work. Anywho, we come here and you can see overall result cycles done, total path, no crashes yet. So I'm waiting for crashes. It's in the first minute, so we'll wait and see. So when there's a crashes, there's red color it's showing, and that's the cool thing. So then you know, okay, on track. I found errors. Good. So remember this like bug bounty, and of course, if you can run it on a cloud, you can of course get more stuff into it, more processing power and things like that. And also paths they covered these two at the moment, so they go through multiple, we say like trees, like paths. So search space is so huge depending on the number of operations that you have. So this is, I'm not going to detail on it, but try to understand they are doing a searching here. All right, so unfortunately there's nothing yet. Oh yeah, so my CPU is working really highly utilized, would say. Load averages, as you can see, that's far shit. All right, so that's right. Okay, and then of course you can see the nice values. I think hope you have learned those nice values. Item is running. Alright. So things are running. That's the AFL, so I cannot see it. So anyway, it's not considered out of memory, I believe. Anywho, you have it here. So I will now see come back later and see what are the crashes. So I'm continuing with my lecture. All right, guys. So it's cool, right? So then, so like I said, Google and all these guys are really using uh, this concept a lot because they have realized that's one of the cool things, right? And then, okay. So basically, it's basically about flows, identify flows. So you put input into software and you find the output, and then you look at the output. If it is buggy, if it is crashes, then you analyze it. So to give out a simple logic, so this is basically how really it works, right? Software input, output applies at any scale, and it can be used for many of these said things, right? Next, so this basically works in software engineering dimension. So this can happen not at the specification stage, guys. So you probably have learned some of these concepts. You can do this verified testing, those things at later stage, right? So it can be quite interesting. And this, what the fuzzing happens mostly at the implementation of the verification stage. So because this is not a software engineering lecture, I'm not going to deep into it, but understanding it and also understanding the would say the ROI of this, because for organization concept like fuzzing can be used like exploitation and things like that. Especially up to this point we have not discussed too much on software engineering because our topics are much different, but software engineering concept, software engineering dimension also, this can have a very important, because whether you want to do fuzz testing in your normal QA and related areas, because normally it's not happening, but especially some of the countries or some of the companies, but nowadays it's more widely used. So that's why you can see, that's why the point that I want to say that Google and other people are doing that. So what the hell other people are not doing it, or why the hell other people are not doing it? So that's one of the core questions. And then when you want to do that, this is basically what you do end to end. You guys have to find out a target application, and then do the fuzzing, or create a fuzzer, right? Create a fuzzer, and then run the fuzzer, and then you analyze the bugs, and then you fix or exploit them, right? So that's what you do. So here onwards, there can be what happened? Here onwards there can be a situation there's no bugs, so then you normally do the process again and again. If there's a bug, yeah. So now see, like this, this is getting very popular these days. So it's a widely used technique which people are using to handle this. So this is something to understand the value and the bug discovery. So depending on your need, you have to find out a place where it can really be used. So otherwise, you will end up just spending your money unnecessarily. So this is like the software economics. I'm not going to go too much into it. Right. So now let's discuss about finding flows. So when you're normally finding flows, right? In terms of software engineering, right? So this is the model that you are supposed to use, finding if there are any inputs that cause security issues at difficult. Another, it's a dynamic analysis. So yeah, so basically in fuzzing you are expecting things to get fail or the crash, and you have one random input, so this can be quite simpler to implement, and this is surprisingly effective. So that's something that you guys have to know. It's surprisingly effective. So see, like here also it took a bit of a time from my what do you say time to implement this, but it doesn't take a long time, or it doesn't have any of my uh, knowledge or any usage to find. So you can see now the crashes are coming, which is really great. I feel good about it. Total crashes too unique. All right. So remember, like we found application which is vulnerable. That's how I found it. But please understand, this can repeat for any other application that you know, right? So the application that you're using everyday life, so this can happen. Right? So find see the crashes. So when it crashes with a sudden input, given input, that's what is needed in crashing. So fuzzing, right? So that's the expectation. All right, so then what you can do is you can look at the fuzzing steps. So you have seen what I've done in the I have done in my demo, right? So same applies here. Pick a target. So I have to pick a target, which is the vulnerability application. Uh, Attack surface. So I have used that attack surface of inputting things into the program API. Fuzzing tool, I use the American or AFL, and then make your target and tool work together, so which I did, and fuzz until done. So basically I'm just doing it currently. I'm just running it, so as you can see, I'm running this. Okay, so now I have several crashes, which is good. I'm waiting for the results. So once I get the results, I can triage them and I can work with them. So I can use tools like GDB. I'll also demonstrate that a bit later on. And then I can find out whether it's a heap overflow, buffer overflow, or what the fuzzing will find out, right? So even it can be of this formatting, whatever, right? So it can be any of these things, which can be quite cool to understand. And then of course who fuzzes, right? So now probably you know that who really do this thing, because I talked about software engineering and all this stuff. So those people are the ones who are really get involved in it, right? So whatever there's an attack surface, so this can be used without much of a difficulty. So as you see here, the developers are also plays a big role. And then, of course, there are other people, consultants, researchers, bug bounty hunters, attackers, curious people for fun, and people like you and me who are studying so to learn cybersecurity. We also do that. And also, regularly, you will find these things in what we say, CTFs also. Right. So then we have to answer this question: what fuzzing is good for, right? So for what particular areas fuzzing can be good. So these are the areas: running lots of tests that you never would, PDF reader. So there's a quite a famous famous and interesting fuzzing based identified vulnerability in PDF crack, right? So there's a tool called PDF crack. So if you have ever used it, so there was a vulnerability found using this fuzzing technique, which probably I'll try to demonstrate in the next session, PDF crack. So these are like common cases which everybody knows about. And also graphics, especially, so graphics can be used a lot. So there's an example for image, instead of using similar images or movie files. So what you can do is you can get several images, say 3 pixels, and then you can convert it to multiple mutated images. So, and then once you do the mutation of the image in multiple types, then we can test this with the fuzzer or fuzzing library, and then you can see how these mutations would or will break the given code. So that's find out in bugging. So this sort of data mutations can be used pretty regularly, right? And of course, browsers can be used, Unix tools, especially Unix utilities. As I can say, our professor, when he found out, he also looked at a very similar situation. So there are a lot of tools which you can use to do this. As an example, for these mutations, there's a tool, I believe I have installed it. Let me try to bring it in. So, okay, my buzzer is working with the fuzzing. right? And I'll bring another one here. Tuk, tuk, tuk. All right, so if I try doing it a bit, so there's this tool which we can use. Let me take it in. Yeah, I got the tool. I'll keep it here. Okay, so right. Oops. Okay, so I tried out a lot of fuzzes. I'll take this guy. Okay, now what I'm going to do is I'm going to use some called ZZUF. So that's another fuzzer. So this is not a very intelligent fuzzer like AFL, but this also can be used. There are so many of them, so much of them. It's called multi-purpose fuzzer again. It's a transparent application input fuzzer. It works by intercepting file and network operation, changing random bits and program input. So it basically can be able to do random changes for the inputs, right? And then as you can see, you can use a seed for the changes, because the seed is important, because when you do the change, if you find out a bug, if you can't redo that, if it won't redo, then you don't find it. So there you find, there's a bug there, but I can't find what the fuzzing, right? So that's where you need to work out the random order with the seed. This seed concept is using crypto. So the same concept is used here as well, guys. So once you go into the seed, the randomness where there's no pure randomness in the computer. It's all stupid. So as an example, I can think of any one of you and say what that bugger is doing. So that randomness, you can't find it in the computer. So that can be only used or gained by having a seed value. And of course, you can have a ratio of randomness with a minus r, right? And then of course, you can have the number of time it runs, number of crashes, ports. So this can be used to fuzz networks, which is cool, right? And yeah, so that's basically it. But the fuzzing. Okay, so what's happening around? Okay, so I think, yep, that's fine. Okay, now what I'm going to do is I'm going to look at, so I'm going to show like basically what you can do here. My machine, there's a small concern, but I know the reason, but I couldn't have time to go through it, but I'll show you what to do. Now here I have a Hex Dump viewer. So this is my Hex Dump viewer. So in your case, if you use a Kali box or a Linux box, please use something like HD, right? So so what I'm going to do is I can do a hex dump, but here I don't have any dump to check. So what I'm going to do is I'm going to read a hex dump from this originator to find out some values. So that's in this dev directory called dev0. So if I type it in, of course, I can find a number of values coming in from different locations, right? So okay, so what I can do now is I can read these values and dump it, and then at the same time I can say read like 100 bits, right? So yeah, so I got this, and you can find the addresses is all 0. Now I'll be able to change it, right? I should be able to change these things and not these addresses, but the values that goes here, I should be able to change, guys. So to change it, of course, I use the fuzzer. So what I have to do is just add it here. So the only concern is probably I'm missing one flag, so I can do ratios like 0.5. Then I can give a seed value of 100 or whatsoever, and I can play this. So ideally there should be some values changing here and there, but unfortunately in my case it doesn't. Something is missing. But anyway, what will happen is you will find some values change, input change, because you're going to fuzz this or fuzz this whatever is sent, right? So this is the logic of using a concept like these different fuzzes, right? So that's another cool option that you have. All right, so okay, now see there are a lot of crashes, 7 crashes. Let's continue and come back again. So the speed is slow, right? That's why. So if I can have fast and can tune the processor to do that, I can get better results. All right, so let's now move on. Right, so as you can see, there are different examples of using, and also it's really famous to use this American fuzzer, right? So I don't know. Of course, these guys, Americans have found it out, so no harm of saying American fuzzer. So for us also better to have a fuzzer. Right, so it's a security-oriented fuzzer that employs a novel type of compile-time instrumentation and genetic algorithm. So they use genetic algorithm, like I said, automatically discover clean, interesting test cases that trigger new internal states. Right, so this is ubiquitously known as AFL. So basically, this is a general purpose fuzzer. It can be used for C, C++, Objective-C, and it's a very fast and clever and also easy to use fuzzer. And there's another fuzzer, very famous fuzzer called libfuzzer, right? So basically, what the AFL fuzzer do, I have already demonstrated it for you. So it's basically instrumentation guided fuzzer. So it knows exactly at what stage it can be implemented, and it's a compile instrument code. So it's based on the compiler, and then it understands the code paths. That's why it showed the different paths which is going to the search space. So it's going to different search spaces and injecting all this bit of codes here and there. And it skips entries that provide subset of coverage. And also it has two different modes, slow and large, and various mutation strategies can be used here. All right, so that's basically about the fuzzer. And this can be used in Docker-based platforms, and also Google Cloud. So I'm not going to implement it right away, but please understand, so please understand that can be done very easily. All right, so basically you will find a structure like this when it comes to implement AFL. And now we see whether, now because we have ran the whole thing, we see whether we can understand it. So this is you, the fuzzer, and then this is your monitor. So I did that. This is my fuzz, AFL fuzz. So basically, what it does, right? It basically find out crashes. It finds crashes. It will be in the crashes folder. So guys, I'm just looking here. I'm waiting for the crashes to do. Okay, let me go back. So ideally, I'm be here. So this is where. Okay. So this is where I have the vulnerable. I ran it here. So I ran the code here, and actually, this is my out crashes folder. So if I find it, go here, I should be find any other crashes. So sorry, I have these folders. So as you can see here, I see the queue folder. So test cases will be here in the queue folder. And then what else? The input, you have seen the input. So input was here, and also this is the program, right? So that you have seen. And if you really look here, so these are called hooks. Later on we'll see, like, find out the hooks, program hooks, not like these really bugs here, but we are not really worried about that at the moment. We'll come to that later on, right? So if you go to crashes folder, guys, okay, I already have some crashes, 1 2 3 4 5 6 7 8. So if I take my where's my other, okay, oh, did I lost my other nope, it's there. Okay, it's already there. As you can see, I have 8 crashes here. So these are 8 opportunities for me to find out different bugs, right? So these are the signature of these bugs, where it is, blah blah blah, the ID, signature, source of code havoc, and some number. So basically, if I'm interested, right, so what I can do, I can go here. Okay. Okay, I am going to check all my hashes. It's still coming, so I'm not going to wait anyway, guys. All right. So, okay. 2 should go here, fuzzing, okay, and then a fair training, and let it start. Alright, that's where I should be. Okay, all cool. Right, so now what I have to do, right, so if I really wanted to find out what's the real problem, so what I have to do is I have to open this up, right? So I have to open this up. So obviously I can use, so this here onwards it's reversing exploitation and all the cool stuff. So I can use GDB and I can load the vulnerable program here. All right. Okay. So guys, thereafter what I can do, I can check disassemble main. So I don't see any value doing this because it's not the purpose. Info functions. Yeah, so you have these two functions, main and the processor. Good. So I can run this. Now there's no, I can of course run this like the same way. I can go to inputs and then I can check the head and run this. Or else what I can do, or ideally here onwards the process is actually to run this with some objective. All right. So the objective is we have to run this with setting the arguments, this particular arguments which are found it here. So these crashes would be our arguments. So to do that, so what I'm going to do is, so I'm going to set arguments and you can say the arguments which are in the out on here, so it should be out crash, no? Out dash crashes, and then crashes folder. So that's a folder that I'm in here, right? So this is, if I do pwd here, this is the folder out crashes, right? So this one is confused. So not sure how many crashes are there yet. Oh, there are 11 of them, which is cool. Right. So now what you can do for one moment, if I go here a bit, I can see 11 here or 12 whatsoever. I can do a cat and see, like, okay, see inside those crashes. These are files. Everything in Linux, they are files. Copy, paste. All right, and then press enter. Oh, see, all strings truncated at position 0. So this is the reality, right? This is the reality. So basically, this can be inputted again. So these are the positions and these are the cases of interest. And then you can insert into the program and can see the memory and what really happened. Truncated the 20th portion, we can have another one like that. So this can be cool. So if you don't understand what is this, and don't worry. I just want you to understand the process. That's all. We anyway we will learn a lot other things on this, and we'll do a full complete practical on how to understand or how to do fuzzing, understand one of the problems, and go through the debuggers, and then you can find out the real issue, whether it's a heat overflow, then write the overflow, and then attack it. So that's a complete process, right? The string or whatever. Right, that's fine. So you understand that. So we come back here now. So now what I want to do is I'm here, crashes, and then I can give that particular crash. Okay. Ooh, what is that? Okay, I pasted the boundary. Okay, I highlighted it, so it's pasted. So I have to go here. So I cannot continue. I have to say copy this. I think it will get pasted here. Paste. Yep. Good. So enter. So ideally, when I run this here, so I have a small concern here, but in your case, it will run and do a segmentation fault. And then once you do that process, it's running, no? Okay. Okay, what happened? So we see. It exceeded normally, so I'm just curious, but backtrace. Okay, no step. Okay, so that's in your case it will work. There's a small concern here. Don't worry, this is from my MacBook, so there's some keychain issue, so I couldn't solve it at the moment. So, but in your case it will work. So anyway, we're going to go from that point onwards and understand the rest in a complete exploitation. Okay, but this is the place where you normally start exploitation. Right. So let me take this out. And guys, still running. So if I run for several days, it's 28 minutes. It can run for hours. You can find thousands of errors, so which I don't have a intention of running right now. Okay, start working. So go. So it says we are done here. Have a nice day. Yeah, we'll do that. Right. Oops. Okay. Right, so now you know the process, how the process map works, and then of course you have to find a proof of case, POC, which will prove that the POC is there. Then you can submit as a bug for the developers. So that's basically what normally will be done in that sort of process. Okay, so then. So what are the pros and cons of fuzzing? That also you have to know. So now we know basically what's really happening in the fuzzing. So if you look at fuzzing, it can be very useful, but there are advantages and disadvantages of fuzzing. So it provides results with little effort. So that's we have seen. Once the fuzzer is up and running, it can be left for hours, can reveal bugs missed in a manual audit. So normally in the audits, you will not find these guys. So it can be hard for some time to find some of those bugs. But provides an overall picture of the robustness of the software also, which is quite useful. Right, and then cons would be won't find won't find all bugs. Fuzzing may miss bugs that don't trigger full program crash. So of course you can miss things, and crash in test cases that are produced may be difficult to analyze. So those are some of those cons. And then of course remember there are different types of fuzzing. There are of course smart ones and dumb ones. So we have looked at two. Smart one we have used was a FL, and the other fuzz method was a bit of a dumb fuzzing mechanism. Right, and then of course there are fuzzers which works with different types of techniques. Mutation, I told you how the mutation works with these images and all that. And then even the second example I showed you was sort of mutation. And also you can use man in the middle fuzzing, so which you'll do in a later exercise. Right, so and then you have to understand the anatomy of a fuzzer. So we have seen like the structure also, but if you want to have a node and all that, so this is like basically the anatomy of the fuzzing. So you have to generate the test cases, record the test cases, interface with the target, and detect the crashes. So once the crash is done, the fuzzing part is already over. Then what we are supposed to do is basically go ahead with the exploitation step. And test case generation is kind of useful. There's another theory behind it. So there are a lot of test cases, but basically this is from the knowledge which is already existing. So the knowledge we use, whatever the existing knowledge we use to do the rest of the things. So these are some of those fuzzing logic. So you can use null characters, new line characters, semicolons, format strings, whatnot. So you can use format strings and so many other things as these test cases, right? So if I write down few of them, so I have a list here. So you can even have things like notepad. So some comments like notepad. So don't ask me why these things are used as test cases, because of the usage earlier. And you can say command injection with some things like command injection. I'm not going to write a whole thing, command injection, and even things like this. So these are all different types of test cases that we can use, as you can see. Of course, there's a logic, but there are some of these characters can be dumb characters as well. All right. So, so as you can see, new line characters, semicolons, all these things will be used, right? And also the fuzzing quality depends on several things, speed, and also you can reduce the test cases, and also the code coverage, the coverage that you are doing using different types of techniques. So that will give the effectiveness of the fuzzing. And also there are cool set of fuzzing frameworks. So we have looked at one or two, and these are some of the other famous frameworks. So you have called Radamsa, all right, flexible, and Sully is another famous one, and Peach, Spike, Grinder, Fuzz, and so many other things. All right, so I have already prepared a note which I'm going to give it to you guys. So this is my tutorial. So I'm going to share this with you. I've taken parts of this from FCQ, so I put the references, guys. So my tutorial, what is fuzzing, pros and cons, smart and dumb fuzzing, types of fuzzers, mutations, replace, man in the middle, blah blah blah, something in the middle, an anatomy of a fuzzer, right, and test case generation, and also reproducibility is very important. If you can't reproduce, you can't build up a POC. So it's very important to have reproducibility. Okay, right, and then fuzzing quality depends on the speed, categorizing crashes, and test case reduction, code coverage, and these are the frameworks. And all right, attack types, fuzzer would try combination of numbers, chars, metadata, so all these things. And also when you're fuzzing, you can start with anything, even the UI can be fuzzed, right? And the command line options, and also protocols can be fuzzed. Any of these things can be fuzzed. So these are some of the, and the mutational fuzzers. You have American Fuzzy Lock, Radamsa, and fuzzing frameworks. You have BFuzz, which I've used. 222 domain-specific fuzzers, Microsoft Minifuzz, Regex, and there are commercial products as well. All right, so it's been a bit almost like 1 hour. So this is like the intro. Hope it was clear to you guys, and you got the very basic idea of fuzzing. What the fuzz? So we go to the next lesson. And we'll do a complete fuzzing exercise, a few demos, and then do a complete fuzzing exercise going into a proper exploitation. So for the moment, thank you guys, and hope happy learning.